Καλησπέρα σας κυρίες και κύριοι. Σε αυτό το βίντεο που θα ακολουθήσει μετά έχουμε ένα πολύ ωραίο βιντεάκι από κάποιον Ιταλό παραγωγό, ο οποίος μας εξηγεί πάρα πολύ ωραία για το πώς κάνει ανάμειξη. Βλέπουμε εδώ μια φανταστική εικόνα, ας πούμε, μια μηχανή του καφέ πελλετ, η οποία δεν υπάρχει βέβαια, την έχω φτιάξει μέσα από ένα πρόγραμμα τεχνητής νοημοσύνης. Απλά στο βίντεο που θα ακολουθήσει θα δείτε πώς κάνει ανάμειξη των υπολειμμάτων του καφέ ο Ιταλός παραγωγός με πριορίδια για να φτιάξει πελλετ αναμειγμένο με καφέ. Απολαύστε αυτό το βιντεάκι και θα υπάρχουν και άλλα τέτοια συνεχόμενα για να δούμε πόσες παραλλαγές μπορούμε να κάνουμε στην ανάμειξη των πελλετ για την παραγωγή ξύλινων πελλετ ή οτιδήποτε άλλο μπορεί να φανταστεί ο καθένας. Απολαύστε.
Hi YouTube, profile is back. Today we talk about coffee and pellet. Let's go. As many of you know, coffee is one of the most consumed and famous drinks in the world. Preparation at home, as well as in coffee bars, consists in having the hot water and the steam passing through the coffee powder, extracting all the flavors and colors that we all love. What remains after the extraction are coffee grounds in the coffee powder that is away and has to be properly disposed. Since we do have a laboratory where we produce pellet, you have seen other videos at the channel, we wanted to explore the biocombustion way, let's say, and we wanted to understand if we can recycle coffee grounds inside. To do that, first of all, we had to understand the composition of coffee grounds. From some online researches, we find out that they are quite rich in oil, carbohydrates, lipids, proteins, all components that together let the coffee ground reach a quite high energy content per unit mass. We are talking about 5,000 kilocalories of energy per unit mass of coffee grounds. Properly converted, you can have 5.8 kilowatts of energy per unit mass of coffee grounds. The question now is, can we compare them to the normal wood pellet? To do that, I checked online the EN Plus technical documentation. The EN Plus is the world-leading certification standard, let's say, and I find out that there are several quality classes, maybe A1, there are other quality classes. You will have an inferior value for the energy content of the final product that is about 4.6 kilowatts of energy per unit mass. And so it's easy to see that coffee grounds have much higher energy content with respect to the normal ground. So it makes sense to do this test because first of all we are finding another way to recycle this product, and second we are increasing the energy content, the calorific capacity of the final product, that is wood pellet, the one that you put into the boiler or into the pellet stove. At that point, we are going to show you some experiments that we made with the pellet mill behind me. We tested different wood types together with different wood and coffee ground percentages in order to find out the best compromise to obtain a good and interesting final product. The first test has been carried out with fir wood chip, 75% of fir wood chip, that is about 14-15% of moisture, together with 25% of coffee grounds. This test that is about this product was okay, but not that much good, because it is not that much compressed. As you see, it breaks in small pieces, and it is not that much shiny and not very resistant, so something that you cannot put inside wood chip boiler or stove. And so this is due to mainly two reasons. The first reason is about product. Fir wood chip is a quite soft wood chip, so it requires much higher compression, and moreover the coffee grounds are oily substances, so for sure they're not going to help the compression of the final product. And second is something that is more mechanically related. This machine is able to mount different ring dies, and these ring dies have different dimension of the holes in terms of length and also diameter, and so you can, by changing them, you can regulate the compression of the final product. Now, you may say, okay, let's mount something that has a higher compression level. Changing the ring die, we do have it, but changing the ring die is not that easy procedure. And so this was a very rapid test. In the afternoon, we had to continue the standard production with a different wood mixture. And so we had not that much time to do this conversion, let's say. So in order to increase the compression level, we had to change the wood chip type. We use chestnut, 5% of moisture. Chestnut wood chip is much harder, and so it requires less compression, so this ring die is okay, and then it has a higher energy content with respect to the fir wood chip. The second test was arranged with 75% of chestnut wood chip together still with 25% of coffee grounds.
Questa è quella buona. Com'è?
This is the result. The final product is much better because it is much more compressed, shiny, but we still have small pieces of wood chip. We want to achieve a bit more of compression. And so the third test consists in having 80% of chestnut wood chip together with 20% of coffee grounds.
Perfetto. Carichiamo.
In this box here, you see the final result. That is something really good, because you have quite long pieces, good shiny, good resistance, good compression, and so we are proud of it. We liked it. At that point, I want to do a consideration. Many of you may have seen during the startup of the machine some small pellet types, very resistant, very hard, shiny and very black, small pieces falling down onto the dustpan. What happens is that when you stop the machine, you have material remaining inside the holes. Typically, when wood pellet goes out of the holes, it is hot, so it is able to expand, okay? If you stop the machine, the material remains inside the holes, it cools down, so it remains compressed, it cools down, and then you obtain a product like this, that is a fantastic product. Very resistant, as you see, totally black, very shiny. This will be something really good. Maybe something that you can obtain with a much higher compression ring die. Maybe we can arrange a test in the future. So, since the third test was the correct one, we decided to simulate a standard production. We mixed 20 kilograms of chestnut wood chip together with 5 kilograms of coffee grounds, that is still the 80-20 percentages. We simulate about 5 minutes of production in order to understand how the machine was working and in order to see the final product. That is obviously still this.
Sono 15 kg.
in conclusion, these were very interesting tests because we showed the capabilities of recycling a product together with augmenting the energy content of the final wood pellet. We also showed that the machine was working correctly because the carbon draws were normal. We talked about 16 amps per hour, meaning that the machine was working correctly, was not under stress. And moreover, the production level were good because we are talking about 200 kilograms per hour, so it was completely fair. So this is the end of the video. I hope that these tests were interesting and that you like them. So let me know in the comment if you have many observations or advices in order to arrange maybe other tests. That's it. Let me know in the comment and thanks for watching. Bye.